hybridization will be done by considering pure atomic orbital having different shape, having different geometry. What does that sp stands here? The s and p stands for the s orbital and the p orbital hybridization. So what is the ground state electronic configuration of carbon here? So it is 1s2, 2s2, 2p6. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Chemical Bonding and Molecular Structure. Under that, we have discussed about the dipole moment and we have learned that what are polar and non-polar molecule, and also we have learned about valence bond theory. Already in our classes, I have explained that valence bond theory is very important for the examination point of view, and also we have learned the differences between sigma and pi bond, and lastly we have observed that this valence bond approach, it is only limited to the diatomic molecules, not for the triatomic molecules. Later, it was explained by Linnaeus Pauling. To explain that VBT, he used the concept known as hybridization. So today, we are going to understand more about the hybridization and types of hybridization. Under that, today we are going to understand only about sp hybridization and sp2 hybridization. Okay, let's see what is hybridization first. Okay, hybridization is an intermixing of pure atomic orbitals of slightly different energies with a different shape to give a equal number of hybrid orbitals of same energy and identical shape, and new orbitals are formed are known as hybrid orbital. So how does the hybridization will be done? Hybridization will be done by considering pure atomic orbital having different shape, having different geometry also. So when they are overlap themselves, results in a formation of hybrid orbital. Let us see what are the silent features of the hybridization. For the hybridization, we need a pure atomic orbital. Is it right? Yes. The number of hybrid orbitals are equal to the number of hybrid orbital that can be get through hybridization, and hybrid orbitals are always equivalent in energy as well as the shape. So when you got that hybrid orbitals, it has an equal energy with an equal shape, and a hybrid orbitals are more effective in forming the stable bond than that of the pure atomic orbital. So when the pure atomic orbitals, when they overlap themselves, which results in a formation of hybrid orbital. Is it right? These hybrid orbitals are more stable when it is compared with a pure atomic orbital. This is the one thing that you need to be remember. When these hybrid orbitals are directed in a space in some preferred direction to have a minimum repulsion between electron pairs, thus it has stable arrangement, and this type of hybridization indicates the geometry of molecule. So when these hybrid orbitals are arranged in a space, it shows that what is the actual geometry of that molecule. So more about this hybridization we'll understand by understanding the types of overlapping. Before that, let us see what are the importance of hybridization. The orbitals which are present in a valence shell of an atom will be get hybridized, and orbitals which are undergoing the hybridization must have what? Equal in energy. And the promotion of electron is not essential condition prior to the hybridization, and it is not necessary that only the half-filled orbitals should involved in hybridization. In some cases, even the filled atomic orbitals can also undergo what? Hybridization. So these are the main uses of hybridization, where even though we always think that for doing this hybridization we need a half-filled atomic orbital. No. Even sometime, the completely filled atomic orbitals which also undergo hybridization to give a hybrid orbital. So more about this we'll understand by understanding the types of overlapping. Okay. So in that types of hybridization, first I'll go with a sp hybridization. What does that sp stands here? The s and p stands for the s orbital and the p orbital hybridization. Okay. This is a type of hybridization involving the mixing of one s and one p orbital results in a formation of what? Two equivalent sp hybrid orbital. So what we are considering? We are considering the one s orbital and we are considering what? One p orbital, and results in a formation of what? Sp hybrid orbital. Okay. This sp hybrid orbital has a equivalent energy. And sp hybrid orbital has 50% of s characters and 50% of p characters. Why it exhibits a 50% of s and p characters? Because it is a combination of what? S and p orbital. Hence it exhibits 50% of s orbital characters and 50% of p orbital characters. And two s orbitals are oriented in opposite direction and with a bond angle of 180 degree. So this is a general introduction to the sp hybridization. Let us see with the example so that you will understand how the sp hybridization will be done. I'll take with the beryllium chloride. So that is the example for sp hybridization. We know that the ground state electronic configuration of beryllium is 1s2 and 2s2. It consists of what? 2 electron in its outermost shell that is present in which orbital? S orbital. Is it right? In excited state, the 2s electrons are get promoted to what? 2p orbital. 2p orbital. So this is a ground state electronic configuration, but in excited state what will happen? One electron from the s orbital gets shifted to the 2p. Okay. So results in a formation of what? sp hybridization. So I can write this is also as in the ground state. Okay. So what is the configuration? It is 1s square and 2s square. Is it right? So it consists of 2 electrons. This is in a ground state. When the beryllium, they get excited, what will happen to the s orbital? So 1s orbitals will be remain as such. But in the 2s, which consists of how many electrons? 2 electrons which get excited and shifted to the 2p orbital. So one electron will be moved towards the 2p orbital, and this is 2s and 2p. These two hybridizations are also known as sp hybridization, which is known as what? sp hybridization. So one 2s and one 2p orbitals are get hybridized to form two sp hybrid orbital, and these two sp hybrid orbitals are oriented in opposite directions with a bond angle of how much? 180 degree. And each of this sp hybrid orbital, they overlap with the p orbitals of the chlorine and forms a beryllium chloride. You can see that this is a beryllium which are having what? The one electrons on the s orbital and 1 electrons on the p orbital. It has been accepted by what? Chlorine. Hence the chlorine which undergo overlapping with the P and a chlorine which undergo overlapping with the S and results in a formation of what? Beryllium chloride, and between these two we have a bond angle of 180. So this is the best example where we can clearly understand how does the sp hybridizations will be taking place in beryllium chloride. So hope you are understood with this example. We'll take the acetylene as a second example. So the formation of acetylene, that is C2H2. In formation of acetylene molecule, both the carbon atom undergo what? sp hybridization. In excited state, carbon has what? 4 unpaired electron, that is the electron in 2s get unpaired and occupies 2p. So what is the ground state electronic configuration of carbon here? So it is 1s2, 2s2, 2p6. There are 6 electrons will be present in carbon. But in excited state, what will happen? So again, the electron which is present in the s orbital gets shifted to what? 2p. So and forming what? 2p. That is s and p orbitals, they overlap themselves and results in a formation of what? sp hybridization. So in the ground state, it has 1s square, 2s square and 2p2. So it is 1, 2 and 2. Is it right? In the excited state, what will happen? So one electron from the s orbital gets shifted to what? Shifted to 2p and results in a formation of what? sp hybridization, which results in a formation of sp hybridization. So we'll understand how many pi bond and sigma bond will be formed now. When two unhybridized orbitals of 2py and 2pz, one sp hybrid orbitals of one carbon atom overlap axially and with another sp hybrid orbitals of another carbon atom and forming carbon-carbon sigma bond. Here you can see that it forming a sigma bond between two carbon atom, where other unhybridized orbitals of each carbon atom, they overlap axially and half-filled s orbitals of the hydrogen forming the bond with sigma bond, and each one with the two unhybridized p orbitals of both carbon atom, they overlap sideways and results in a formation of what? Pi bond. Here you can see that between the carbon atom we have a sigma bond, and between the carbon and hydrogen atom you can see that there is a formation of pi bond. This is how we can clearly understand that in sp hybridization there will be a formation of sigma bond as well as there is a formation of pi bond in acetylene molecule, and showing the linear structure, and also it has a triple bond between the two carbon atom, and you can see that it has a bond angle of 180 degree. Okay. Now let us see what is sp2 hybridization. Now we have understood that what is sp hybridization by understanding with the beryllium chloride and acetylene molecule. Now let us see what is sp2 hybridization and what are the examples. Okay, this is a type of hybridization which involves one s orbitals and two p orbitals. One s and two p orbitals in order to get what? sp2 hybrid orbitals. And the three hybrid orbitals are oriented in the trigonal geometry. It is very, very important. Trigonal planar geometry, and with a bond angle of 120, and sp2 hybrid orbital has what? 33% of s characters and 66% of p characters. Okay, here you can see that this is a shape of s orbital and this is a double shape of p orbitals. When they overlap themselves, results in a formation of trigonal planar structure. So that is why while understanding this, or when you are writing the sp2 hybrid orbital, you must remember that always it has a trigonal planar structure or trigonal planar structure, okay, where it shows a 33% of S characters and 66% of P characters, okay. We'll take the example of BCl3 molecule, that is boron chloride molecule. The ground state of electronic configuration of boron is 1s2, 2s2 and 2p1. In excited state, the 2s electrons are promoted to the vacant 2p orbital and results in a formation of unpaired electron. So, whereas in case of chlorine, it has how many electron? It has 17 electron. You can see that electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p5. Is it right? And this is a general ground state electronic configuration of what? Boron, which has 5 electron. But when electrons are get excited, one of the electron from the s orbital will move towards the p orbital and forming what? 3 unpaired electron. So that is why this 3 unpaired electron, which results in a formation of what? sp2 hybridization. Why it is known as sp2? Because 1s and 2p orbitals are overlapping themselves, or when they undergo hybridization, it forms what? sp2 hybridization. Okay, here you can see that the boron has 3 unpaired electron which has been given by the chlorine. So 3 chlorine atom, they shares 1 electron with the boron and results in a formation of beryllium chloride, and you can see that this is a trigonal planar structures with a bond angle of 120. So this is a main characteristics of what? sp2 hybridization. Now let us take another example of ethylene, which is a alkene. Okay, so ethylene is an example. So in the formation of ethene molecule, both the carbon atom is undergo sp2 hybridization and it has 4 electrons in its outermost shell and it is unpaired. Okay, and electron which is present in 2p orbitals are get unpaired and occupies to the 2p orbital. Let us see, this is a ground state electronic configuration of carbon atom which are having how many electrons? 6 electrons. Similarly, in excited state, what will happen? Already we know that in the 2p, it consists of 1 electron in the 2px and 1 electron in 2py. But in the excited state, 1 electron from the 2s gets shifted to 2pz and forms of 4 unpaired electrons in the carbon. And these 4 unpaired electrons, they forms the double bond with 2 hydrogen atom and forms a ethene structure. That is why when you are writing ethene, we write double bond between 2 carbon atom, because the 2 carbon atoms, they overlap themselves and results in a formation of sigma bond. Similarly, the unpaired p orbitals, they overlap themselves and results in a formation of pi bond. This is how, when we are writing the structures of sp2 and sp hybrid orbital, we can easily understand how this s and p hybrid orbital, they overlap themselves to also form a sigma bond and pi bond. So, hope you are understood with this concept. In the next session, we are going to understand only about sp3 hybridization. We'll see what are sp3 hybridization. We'll discuss with a few examples so that we will understand for our final board. So, by this, I like to say that which are all the concepts which I had covered in the hybridization concept, that is SP and ISP2. It is one of the basic concepts for your board as well as for your CET. So have a look on it and have a basic concepts about hybridization in the chemistry, and it's too important for the competitive exams also. So we'll meet you with the next session. Till that, take care, be safe. Thank you.